Okay guys, I'm learning this question paper here, grade 10 from November 2018. I got paper 1, maths paper 1. So, let's some questions come inside of the question paper. Okay, more question 1 and 2. Then, okay, let's look at this one. Now, question 5. If you look very carefully, we have a function here. That one. We have a function, then function here now it consists of a graphia parabola, le graphia, le an exponential graph, and get you two, but it really on the same set of axes. Then before we can answer any questions, because as you can see we have some questions down here, because before we can answer those questions, firstly I revalue the statement say okay, the statement says sketched below are the graphs of fx equals ax squared plus q and gx equals half to the exponent of x then minus 4. Then they continue to say a and b are the x-intercepts of f. The graphs intersect at a and point E lies on f. Then C is a turning point of graph f and D is the y-intercept of G. So that's the statement there. It's just a statement. What does this graph consist of? Then let's read the questions now. 5.1, they say we must write down 5.1.1 get the coordinates of D. So what are the coordinates of D, right? Okay, the coordinates of D, let's see. This is D. Let me show you which way D came. This is D there. D came y-intercept because the point here D is exactly on the y-axis and it cross I can get Graphia G, the exponential graph. So we're gonna answer the question here, the coordinates of D. Okay, if D is the y-intercept, and every time we calculate the y-intercept, you know that you must let, when you calculate the y-intercept, you must let x equals 0, right? Let x equals 0. That is the law. So if D is the y-intercept, it means that more dx is equal to 0. So this is what I'm going to do. For us, okay, we already, when we calculate the coordinates of something, the x coordinate, the y coordinate. So the x coordinate, we already say it's 0. What's your time? The y coordinate. How are we going to calculate it? Okay, let me show you. I'll do this. Okay, we're going to use the equation. There is an equation written gx equals half to the exponent of x minus 4. That equation is the equation of graph G. And point D, graph G crosses that point here D. So if it goes through that point, it passes that point, it means that the equation here G is applicable in this case because D is a point on the graph here G. So I'm going to write it down. Let me do this. So let me write it down here. The equation here, gx, we have gx equal half to the exponent of x, then minus 4, right? Okay, gx, we can write it as y. No gx, we can just put y instead of the gx, right? No y, it represents a y, then equals to half. Remember, d is the y-intercept, x should be 0. So in the place of x, I'm going to write 0, then minus 4. Then I'm going to say y equals to, then really half to the exponent of 0. And get anything, any number, if you raise it to the exponent, there's 0, it should equal to 1. So right now half to the exponent of 0, we're just going to write 1 because it's equal to 1. And get anything to the exponent of 0, it's equal to 1. Then you have a 1 minus 4. Then 1 minus 4 is going to give us negative 3. Meaning the coordinates of D in this case, therefore the coordinates of D in this case, our x is 0, then our y is what? It's negative 3. Then you're done. This is very simple level. Very, very easy. As long as you can know what it's the y-intercept, then you can know what you should substitute 0 in the place of x, then you're going to be able to solve it very, very easily. Then this is the answer. We are done with point D. And to show what the y is negative 3, it is a negative. To show what it should be a negative, let me show you. I'm going to show you something again. Okay. The place where D is, it's on the negative side of the y-axis. That's why our answer y is negative. If it was positive, then we were going to question the answer, or hey, why is it positive molar d is on the negative side of the y-axis? So to prove that it's correct, it's negative, just like the point where d is. Then I think now we can go to the next question. Okay, let me rub off the answer for the first one. Okay, I'll do this. Wait. Range. Let me just zoom a bit. Okay. We go to the next question, 5.1.2 again. Okay, let me take it a bit higher so that everyone can see it. Okay, like when I'm 5.1.2, they say the range of graph G. First of all, you must know that when they talk about the range, they are talking about the y values. So when I got the range of graph G, they want the y values of graph G. Graph G, don't forget, get the exponential graph. So we're going to write the range of the graph. So let's do it like this. Let me zoom it in for you so that you can be able to see the graph very clearly. Okay, graph G is this one, the exponential graph. So we are supposed to write the range. Range meaning you're going to look at the lowest point and the highest point of the graph. The lowest point and the highest point of the graph in terms of the y-axis. So let's start with the lowest point. The lowest point of the graph, and we have an asymptote. Like one of this dotted line. This dotted line is the asymptote of graph G. What is an asymptote? An asymptote, we are talking about a barrier for the graph where the graph cannot pass or cannot cross the line. So if we have an asymptote, this dotted line, it shows us when graph G cannot cross this point. And so it cannot cross that point, meaning what it doesn't go lower than the asymptote, meaning what the negative numbers that are after that asymptote, that Graphia G, it doesn't cross those points. Okay, so first of all, the asymptote key. What is the point on the y-axis? What is the number that is here? The number that the asymptote passes. We need to know the equation of the asymptote. How are we going to know that? Okay, let's do it like this. I'm going to indicate that for you. Okay, let me remove the color. Okay. Okay, since we are dealing with Graphia G, we're going to look at the equation again. The equation here, gx equals half, then to the exponent of x minus 4. Gx equals to half to the exponent of x minus 4. That's where we're going to get the asymptote for the graph. The asymptote is what? Is the last number. Like when I call only negative 4. That negative 4, it represents the asymptote. Usually, when substitute number, that negative 4, it represents q. And get q. So the q, it's the asymptote of the exponential graph. So negative 4 is what? Is the equation of our asymptote. The negative 4 that is here. This negative 4, like one on the equation. The equation of the asymptote. What are our asymptote is what? Is y equal to negative 4. Like this. Our asymptote y equal to negative 4. So if this is our asymptote, then it already gives us a guideline or the range. Which boundaries. Okay, so first of all, we know the graph doesn't pass the asymptote to negative 4. So we're gonna say negative 4. Then we say what? We say less than y. Less than y again. When we say it's less than y, we mean the y points at the graph, they don't go under negative 4, and they don't reach negative 4. So that's what we mean. So we take negative 4, then we put it less than what? Less than y. Because the range scalar level will the y values. Then from there, we look at the highest point. And the asymptote is the lowest point of the graph is negative 4. It doesn't pass negative 4 actually. Then the highest point of the graph, it goes like this. So we can see what is the height of the graph? Where exactly does it reach? There is an arrow here. This arrow indicates that the graph is continuing. And this one doesn't have an asymptote, so it doesn't have any restrictions. As it goes up, as the graph of G goes up, I want to no longer it is restricted because there's no asymptote up here. It's not there. Meaning that the graph will continue to go up without any restrictions. And because there's an arrow, it shows what is continuing. So it doesn't have a point no longer it stops. The graph doesn't show us a point no longer the graph stops going up. Because of the arrow, it shows us continue going up. Meaning what we're going to say up until what? Positive infinity. So if negative 4 is what? Is less than y. What are y is greater is from negative 3 upwards. Up until where? Positive infinity. Up until positive infinity. Positive infinity meaning what? It doesn't stop going up. Then this is the range. You are done. Negative 4 less than y. That's it. You're done with it. Or you can just say, you can write y is greater than what? The negative 4. Yeah, let's put it like this. Y is greater than what? Negative 4 is greater than what? The asymptote. Then that's it. You're done with it. Okay. Then we go to the next question. And note that I've wrote it set builder notation. You can also write it interval notation. If you want to write it interval notation, you just write y element of. Then you have negative 4 up until positive infinity. We write it like this. This is interval notation. Then yeah, okay, let's go to the next question. Let me just rub off this one. Okay, the next question, 5.2, where we must calculate 5.2.1, the coordinates of A. Where is A? A is the x-intercept there. I don't know if you can see it. Let me zoom it in. A is what? Is an x-intercept. It's a point of intersection of the two graphs. Point A, graph G and graph F are crossing each other. Then they told us in the statement that A and B are the x-intercepts of F. So A is an what? It's a what? It's an x-intercept. Meaning what? Y is equal to 0 at that point. Okay. So let's write it like this. If we're going to calculate the coordinates of A, we're also going to use the Graphia Gx, because the exponential Graphia G, it also passes point A. So we're going to use that same equation here, Gx equals to half, then x minus 1. Okay, then let's write it down. Okay, so let me write that equation here, Gx, so that we can be able to use it for the coordinates of A. It's gonna be Gx, yeah, equals to half, then exponent x minus 4. Okay, Gx, don't forget y. So y equals to half, then x minus 4. Remember, A is what? It's an x-intercept, so meaning that y is gonna be 0. Vice versa. Really x-intercept y can even 0, but really y-intercept x is 0. So put it like this. Half, then x minus 4. Okay, then from here, this is what we're going to do. We can just take negative 4 to the other side and get, yeah, like I'm with the side as 0, then it becomes positive. Then that equals to half exponent x. Then that's what we're going to do. We're going to write it in a different way. Retro 4, I'm going to take 4 and write it as 2 squared. Let me just write a bit higher here. I'm going to take 4 and I write it as 2 squared. Then I say equals to, then a half. For half, I'm going to write it as 2 to the exponent of negative 1. If you say 2 to the exponent of negative 1 on your calculator, the calculator will write half. It will give you a half. How do you do it? If you have 1 over 2 like this, you just take this 2 and you will take it to the top, to the numerator. When you take it to the numerator, the exponent here 2, it changes to a negative. Remember, 2 has an exponent of 1, because they don't write the exponent, it's 1. So when you take it, the sign of the exponent, 1, it changes to negative 1. That's how we get 2 to the exponent of negative 1. Okay. Then, from here we just put the, remember we have an x, we put the x outside of the brackets like this, then that 2 squared equals to, then negative 1 times x, we multiply them, it will give us 2 to the exponent of negative x. Meaning what, now that the base is the same, we have a base of 2, and we can equate the exponents. Negative x, we bring it to this side, you have a positive, then raja 2, we bring it to the other side, you have a negative, like this. Then x is equal to negative 2. We are done. That's how you calculate what the coordinate of A got. We are done with this question. I hope it's understandable. Okay, let's go to the next one. I'm gonna wrap this off now. Okay guys, so now the level of 5.2.2 again. 5.2.2, they say we must calculate the values of A and Q. When they say calculate the values of A and Q, the question must be, or A and Q, where exactly is A, where exactly is Q? Because one of these ones, they are small letters A and Q. We know what they are not any points, as I already got the points on the graph, right? So where exactly is A and Q? It's in the equation here, fx mock. If you look very carefully, the equation here, fx, where they say fx equals to ax squared plus q, that's where we found A and that's where we found Q, right? So we can use that equation there, or recalculate A and Q. But the only challenge is A and Q are in the same equation. So if you have two unknown values in the same equation, you cannot just use that equation only or solve for the two values if they are in the same equation. So you must create simultaneous equations. Okay, so the question is simultaneous equations to calculate the value of A and Q. Simultaneous equations, how exactly? Okay, let me show you. We're gonna use 2 points. Let's look at graph F. For graph F, we can use 2 points. Like on a point E. Point E with the coordinates of 1 and 3, because it has the coordinates no longer we know the value of, we can use that point E, right, substitute it into Graphia fx, because the point here E is on top of the Graphia f, so we can use it. Then we need another equation, we need at least 2 points. We need another point, not another equation, another point on the Graphia f. Another point that we can use is point A. Point A we calculated just now. Okay? So we're going to use the coordinates down to point A and point E to calculate the value of what? Of A and Q in the equation here, graph F. So, okay, let me write the equation here, graph F here, then we can substitute with the points. Okay guys, the coordinates that I'm indicating to you, get this one. This is Yenga, with the coordinates here 1 and 3. Then as well as point A. Point A, like we just calculated. Then the equation that I'm talking about, the equation of fx up here. Then those are the ones that we're going to use. Okay, then let's do it like this. I'm gonna rewrite this equation here, fx, and one of us, let me write it down. Okay. Okay, fx is equal to ax squared plus q. Let's start with the coordinates here, E. The coordinates here, E king. Let me write them down. The coordinates of E that we have, Q1 and 3, remember? Like we saw up there. So we're gonna write more in the place of fx. Remember it's y, it's y here. So our y more kicking get 3. So it means that I'm gonna write 3 in the place of y there. 3 equals to a. Then our x is 1, so in the place of x, I substitute with 1, then it's 1 squared plus q. Right. Okay, then we can simplify it further. I'm gonna like this. We're gonna write 3 equals 1 squared is 1, then 1 times a, so equal to a plus q. You just simplify it, just say 1 squared is equal to 1, then 1 times a is what? It's a. Then equal to 3 equals to a plus q. Then now we're going to use the other points for a. The coordinates a, remember we calculated them just now. Okay, it was the x-intercept, or our x is 0, it was 0. And then our, oh sorry, not our x, our y was 0. Then our x no longer recalculated. Okay, wait. was negative 2. Okay, then we're gonna substitute these points as well. So this one is gonna be equation 1. I'm gonna be simultaneous equations. This is equation 1. Then equation 2, in the place of y equals to ax squared plus q. More y, I'm gonna write what? 0. Okay, then got equals to a, then x, I'm gonna put what? Negative 2, then equal to negative 2 squared plus q. Then we simplify it as well. Negative 2 squared, negative 2 squared. Guys, another thing, please don't differentiate. Let's go negative 2 squared. Negative 2 squared, whereby you put the negative 2 in brackets, then the squared outside. That one is going to give you 4. Mara, if you write negative 2, then you square it on the calculator without putting the brackets, it's going to give you negative 4. So that's why it's important where it's necessary to put the brackets. Okay? So negative 2 squared more here, and now with brackets is going to give us 4. Then 4 times a is going to be 4a plus q equals 0, like this. Then this is our equation 2. Okay. So since there are only 2 equations here, we're going to be solving them simultaneously. We're going to be solving for a and q simultaneously. What we can do, we can use substitution. For example, like there are one variable, the subject of the formula in a certain equation. For example, let's use this equation here, 0 equals to 4a plus q. Okay? Regard there are q, whatever the subject of the formula, Ramala q, and get equals to what? To negative 4a. Okay, what gets confused about you? Let me start it like this. Okay, we are going to take this q and get to the other side. Yeah, then you have a negative q, then equals to 4a, and get like this. Then what we just do, we take the negative sign here q, we so that it can be positive, and or we can say we divide by negative 1 come, then if we global positive q, then 4 it will become negative, like this. So we write it like this. We want a positive q, and then the negative sign, we can just say return negative sign, then Raisha to the side there 4a, then so that q can be positive. Then if we say q is equal to negative 4a, then we can take the q right, substitute our equation 1. Our equation 1, don't forget, okay, this one, 3 equals to a plus q, right? So now that we substitute, how are we going to do it? Okay, let me rub off more dim so that I can write it. Record 3 equation 1, then equals to a, and then plus, then in the place of q, since q is equal to negative 4, it means that in the place of q we can write what? Negative 4 rasamala q, negative 4a, negative 4a. So in the place of q, I'm going to substitute with negative 4a like this, because we say our q is equal to negative 4a. Then negative positive sign a key times the negative sign of a negative, so equal to a minus 4a. Then a minus 4a, when you calculate it, let me write it in more visible letters. So it over 3 equals to a minus 4a. A minus 4a is equal to what? It's equal to negative 3a. So it over 3 equals to negative 3a. To get the value of a, it's just a matter of dividing by negative 3 on both sides. Yeah. So I'm going to divide by negative 3 on both sides so that I can be left with a. Then the negative 3 will get cancelled on this side. What a fell. A. Then equals to, then this side positive here, when we divide it by the negative, it will find a negative sign. So I'm going to write negative, then 3 divided by 3 is what? It's 1. So it will be negative 1. A is equal to what? To negative 1. Then we are done with A. And what's your time? Q. We also need to calculate the value of Q. So to calculate the value of Q, we're going to use the A that we have solved already. We can just use let's use this equation. Like one equation here, yeah, Q is equal to negative 4A. So when we write it, we can just write Q is equal to what? Q is equal to negative 4. Then in the place of A since it's equal to negative 1, in the place of A, I substitute with negative 1. like this. More of negative 4a, I write negative 4, then I write negative 1 in the place of a, because a is equal to negative 1. Then negative 4, when you times it by negative 1, is going to give you a positive 4, meaning q is equal to 4. Then this is the answer. So we are done with what? With calculating the values of a and q. You just do it like this simultaneously, then you're done. Okay, yeah. Library is very simple, guys. Very simple. The main idea, you must find 2 points on the graph that you are looking for. If you want the equation, yeah, the graph of f like this, you look for 2 points on the graph that has known values so that you can substitute them into the equation. Okay, then let me remove everything that we've written here. Okay, then you know what, guys, then I'll finish up some of them, the rest with you in the next video. Remember, right now I'm treating question papers because I know that people must be preparing themselves for the final term. And yeah, so this was a grade 10 question paper. I even have a grade 12 question paper there on the page. So this is what you can use for practice. Remember, I told you that I'm gonna be posting the topics, different topics from term 1 up until the last term, because term 4 consists of everything. Yeah, the term Kamkanarajon. Yeah, so that's why I'm doing this for you guys. And another thing, for you to thank me for helping you with whatever you need help with, the topics like functions, because I know that they trouble a lot of people cannot necessarily understand them very well. So that's why I'm making videos on this, the most difficult topics. So for you to just thank me for this, you can just subscribe. Subscribing doesn't really consume, it doesn't take anything from you. Actually, it's very easy. You don't really need to do like a lot of, it's not a lot of like administration to subscribe. So please subscribe to my channel, and also like the videos, guys. Like the videos. If they are really helping you, make sure that you like the videos. And then again, if you want sessions whereby I'm going to teach you personally myself, whereby you can be able to ask me questions, and just like the math sessions, you can just contact 0817031197. Then you're going to get your assistance. And guys, okay, thank you so much, guys, for watching this video and for liking. I'll see you when I do the next video. Bye.